Hey everyone, welcome back to the channel. Today we are going to discuss how to design systems for high availability while also balancing the cost and complexity that come with it. High availability is essential for many applications, but it often comes at a high price. In this video, we will explore different approaches to keep your systems available and discuss how to make smart decisions that prevent overspending or unnecessary complexity. Let's get started. First, let's understand what is high availability. High availability means that your system is operational and accessible for the vast majority of the time, often represented by uptime such as 99%, or even five nines, which is 99.999%. These targets define how much downtime is allowed. For example, a 3 nines, that means the uptime allows about 8 hours of downtime per year. In 4 9 system means less than hour of downtime annually or a year. Think about cloud services like AWS or streaming platforms like Netflix. They are designed to stay up even during incidents. But achieving this kind of reliability isn't simple or cheap. Okay, let's talk about strategies for high availability. The first thing is redundancy. Redundancy is the foundation of high availability. By having multiple servers, data centers, or networks, you can ensure that if one component fails, others are ready to take over. This prevents single point of failures. Taking an example for that, if you have a web server that's critical for your business, having a second server that can take over immediately if the primary server fails provide redundancy. This way your users won't experience any service disruption. Let's talk about the cost consideration in the redundancy. However, redundancy can be expensive. Running multiple servers means increased cost for hardware, software, and maintenance. So it's important to evaluate what components need redundancy and what can have reduced redundancy. By this, you balance the cost. Second, load balancing. Load balancing is another key technique. Load balancing distributes traffic across multiple servers, which helps prevent any single server from being overwhelmed. In active setup, multiple servers are actively handling requests. If one fails, the load balancer routes traffic to the remaining servers, ensuring uninterrupted service. And if you want to know about how to balance the cost of that, load balancers add some complexity to your architecture, but cloud providers like AWS and Google Cloud offer managed load balancers, which simplify the setup and reduce operational complexity and also give you better prices in terms of costs. Okay. Number two, the next thing that we need to talk about, which is choosing the right level of availability. First, you need to understand the requirements. The first step is balancing cost and complexity. The first step in balancing cost and complexity is to understand your availability requirements. Does your system really need 5 nines of uptime, or is 3 nines sufficient? The level of availability you need depends on your use cases. Mission critical systems like healthcare or financial systems need very high availability because failure can have severe consequences. Non-critical systems like internet tools may not need such that level of high availability requirements. So every 9 you add to your uptime target, like going from 3 nines to 4 9, significantly increases the cost and complexity. So it's important to determine what makes sense for your specific scenarios. Number two, you need to identify critical components. Focus on critical components for high availability. Not every part of your system needs full redundancy or failover capabilities. Identify the most critical services, those that must be stay up even during a failure, and prioritize them. For example, in an e-commerce application, the checkout service is more critical than a product recommendation service. If recommendations fail, users can still make purchase. So, focusing high availability resources on the checkout service first makes more sense. Okay, let's talk about some techniques to balance cost and complexity. First, use managed services. Managed services provided by cloud platforms can greatly reduce complexity. And instead of setting up your own load balancers, databases, and monitoring, you can leverage managed services that are built with high availability in mind. An example for that, using AWS RDS, which is Relational Database Service, for your databases, provide built-in failover capabilities without you having to manage the underlying infrastructure. This significantly reduces both complexity and operational overhead. Second, MultiAZ and MultiRegion deployments. MultiAZ, which is multi-availability zones, and multi-regions deployments can increase availability by spreading your resources across different geographic locations. This way, even if one zone or region goes down, your services continue to operate. However, deploying across multi-regions can be expensive, so it's better to consider this option for critical services. Start with multi-availability zone for most applications, which is less costly than multi-regions, multi-region, while still providing a good level of redundancy. Number three, use Autoscale to control costs. Autoscaling allows you to dynamically add or remove resources based on demand during peak times. You can automatically scale up servers to handle increased load, and during off-peak times, you can scale down to save costs. For instance, if you run an online store, traffic may peak during holiday sales. Autoscaling lets you handle those peaks without paying for extra servers, helping to manage costs effectively. Let's talk about a real-world example of high availability design. Netflix is a great example of a company that prioritize high availability without unnecessary complexity. They use a multi-region deployment and auto-scaling to ensure that users can continue streaming regardless of any regional failures. However, they also focus on optimizing costs by only scaling up the infrastructure when demand increases. In the example 2, there is AWS Multi-Availability Zone RDS. Another example of it, it provides automatic failover between availability zones, meaning that if one zone fails, the database will still be accessible from another zone. This ensures high availability while letting AWS manage the complexity for you. Okay, let's talk about best practices of designing high availability system. First, prioritize critical services. Ensure that the most critical parts of your system get priority when designing for high availability. Not every service requires the same level of redundancy. Number two, implement regular health checks and monitoring. Health checks and real-time monitoring are crucial. Tools like Datalog and New Relic help monitor system health and detect issues early before they impact users. Balance high availability with cost by using tiered availability. With tiered availability for different services, your core service may need 5 nines of uptime, but other services might need only 3 nines. Applying different availability levels to different parts of your system helps manage costs and complexity effectively. So, to wrap up, designing for high availability requires striking the right balance between uptime, cost, and complexity. Some key strategies keep in mind redundancy and load balancing for crucial systems, leveraging managed services to reduce complexity, implementing auto-scaling to manage costs effectively. Remember, not every system needs the same level of availability. Understanding your requirements and applying appropriate strategies will help you achieve high availability without overspending or overwhelming your infrastructure. If you found this video helpful, give it a thumbs up, subscribe, and hit the bell icon to stay updated with more videos like this. And as always, drop any questions or thoughts in the comment section below. Thanks for watching, and I will see you in the next video.